In this video, I'm going to show you how to do mole to mass conversions. So molar mass is the generic term for the mass of 1 mole of any substance expressed in grams per moles. And it's the same as a couple of other terms, like gram molecular mass. That would be specifically the term we would use if we were talking about molecules. Gram formula mass is what we would say if we were dealing with the mass of an ionic compound. Or gram atomic mass, which is what we would use for elements. But you can generically just say molar mass for any of these three if you want to cover your bases. So I would like you to pause this video and on scrap paper try to calculate the molar mass of the following and also tell about what type it is, whether it's a molecular compound. If it's a nonmetal bonded to a nonmetal, you'd say gram molecular mass. If it's an ionic compound, a metal bonded to a nonmetal, you'd answer your answer as gram formula mass. And if it's just an element, you'd say gram atomic mass. So remember from the video you watched, the last video, all you need to do this is look up the masses of each on the periodic table and add them together. So go ahead and pause the video, and when you're ready, unpause it and see how you did with your answers. Okay, let's go over these. We have the first one is 78 grams per mole, and that would be gram formula mass because we have sodium, a metal, bonded to sulfur, a nonmetal, so this is an ionic compound. Our next is 92 grams per mole, and that would be gram molecular mass because we have nonmetal bonded to a nonmetal. The third one is the easiest. You just look up carbon on the table. It's about 12 grams per mole, and that would be gram atomic mass. The next one is 164 grams per mole, and that would be gram formula mass, metal bonded to nonmetal there. In the next one, we have 180 grams per mole, and that would be gram molecular mass, all nonmetals. And in the last one, we would have 149 grams per mole. And that was a tricky one. That's gram formula mass. Now, you don't see any metals there, but NH4 is a polyatomic ion with a +1 charge, and phosphate is a -3 charge. So we get a positive and negative charge. This is an ionic compound. So since the molar mass is the number of grams in 1 mole of atoms, ions, or molecules, we can make conversion factors from these to change between grams of a compound and moles of a compound. So let's do some example problems. How many moles is 5.69 grams of sodium hydroxide? So as with any conversion problem, we start with what they give you in the problem, 5.69 grams of sodium hydroxide. And then we set up a bracket. I want grams and grams to cross off, so I'm going to put grams on the bottom here, and I'm going to put moles on the top here. So I need to figure out how many grams of sodium hydroxide there are in 1 mole of sodium hydroxide. So sodium hydroxide is made up of sodium, which if you find it in period or on group 1, it'll weigh about 23 grams. It has an oxygen atom, which weighs about 16 grams, and it has a hydrogen atom, which weighs 1 gram. So we add that up and we'll get 40 grams per mole of sodium hydroxide. So that's going to go on the bottom, 40 grams of sodium hydroxide in 1 mole of sodium hydroxide. So now grams and grams will cross off, and I'm left with moles of sodium hydroxide. So in my calculator, I punch in 5.69 divided by 40, enter, and you will get 0.142 moles of sodium hydroxide. Let's try this next one. How many grams is 2 moles of PbNO3, 2? So we'll start with the 2 moles of PbNO3, 2 and set up our bracket. Now we need to find the molar mass. We're going to need to multiply by the molar mass in this type of problem. So we go to the periodic table and we find lead. Lead weighs about 207. I, for some reason, have 207.2 grams. You can round to 207 if you'd like, or you can copy down what I have, your choice. PbNO3, has 2 nitrogen atoms, so this little 2 outside the parentheses means I have 2 of everything in this parentheses. So nitrogen weighs 14, but it's 14 times 2, which is 28 grams. And then I have 6 oxygen atoms. So oxygen weighs 16, And I have 3 oxygen atoms within these parentheses, but again, this little 2 on the outside acts as a multiplier. So 2 times 3 is 6 oxygen atoms. So 16 times 6 is 96. If we add all of those together, their masses will equal 331.2 grams. So that, of course, is going to go on the top because I want moles and moles to cross off. So 1 mole of PbNO3, 2. I have 331.2 grams of PbNO3, 2. So we'll cross off moles and moles and be left with grams. In your calculator, all you need to do is type in 2 times 331.2, enter. That'll get you 662.4 moles of sodium hydroxide. So like any conversion problem, always start with what they give you. They have to give you some information in the problem to start with. You're going to make a conversion factor that's going to get rid of the units that they start you with and end up with the units that the problem is asking you to solve for. And when converting from grams to moles or moles to grams, you're always going to need the molar mass of the substance that is in the problem. You'll always get this from the periodic table by adding up all of the masses of the elements in the compound.